Hi everyone, in the given problem statement of Jump Game 2, you are given a zero-indexed array of integer nums of length n. You are initially positioned at num 0. Each element of num I represents the maximum length of the forward jump from index I. In other words, if you are at num I, you can jump to the nums I plus j, where a lot of condition is given and we have to return the minimum number of jumps that is required to reach to the last element. So we are already given one condition that it is guaranteed that you can reach the last position. So in all of the test cases, you will always reach to the last element. Now let us take the example of 2, 3, 1, 1 and 4. So initially you are at the 2. So here you can make a jump of 1 step or 2 step and you can land at here, or you can land at number 3. Similarly, from number 3 you can jump to 4 and go to the end or make 1 or 2 jumps. Because here we have to maximize our jump distances so that there is a minimum number of jumps. So our correct answer would be from 2 we have jumping 1 step to 3, and from 3 we are jumping to the 4. Now how to do it? So in order to do it, we are going to introduce two variables, L and R. Both of them are going to be 0. So initially let us again take these values 2, 3, 1, 1 and 4. Initially you are going to be at second position. So from 2 we are going to make a jump till 1 because we are going to maximize it. So right now our L is 0 and our R is going to be 2. So from 0 to 2, right, we are going to find out what is the maximum distance it can reach. Okay, so number 3 is going to be from this position 3. So 3 is at index 1. So index 1 plus 3 is equal to 4. So from 3, can we jump towards 4? Answer is true. And we can jump to 4. So how to write it up? Let us take another example. 2, 3, 0, 1 and 4. Initially both L and R is going to be 0. So from 2, the maximum jump that we can make is still 0. Okay. Now 3, the maximum jump we can make is till 4. So we have to maximize our jump that we can make. So between 3 and 4, if there is any more element which can reach to the furthermost point more than 4, we are going to introduce it. So if I have to write the pseudocode for it, so here we can write something called res 0, which is going to denote the jump that we're going to make. We are introducing two variables, L and R. Both of them is going to be 0. We are going to introduce a while loop, which a condition so that the R, the rightmost pointer, is always going to be less than length of nums minus 1, denoting that we are reaching to the furthermost point. And we are going to introduce a variable called furthermost equal to 0. Then from the furthermost, like for example from 3, so once we reach to, let's say 2 to 0, right, so any values within this range, right, we have to find within these values, right, which values are going to reach to the furthermost point. So we can write in, so for I in range of L to R plus 1, because how Python works, you have to give the entry value plus the last value plus 1. And here we are going to say furthermost equal to max. So if our furthermost value is already maximum, so in this case, right, the furthermost value is 4. And in this case, the furthermost value it can reach, right, is nums of, let's say 0, 1, 2, nums of 2, plus it is at second position. So here the furthermost is 2. So 2 or 4, the maximum is going to be 4. Similarly, this is 3. So 3 plus 1 is 4. So max of 4 comma 4 is going to be 4. So you have to find in the max of furthermost comma nums of I plus I, means basically the value that is present here and what is its current index. And once this entire loop is done, so we are going to change our values. So left hand side or left index is going to become R, and R is going to be furthermost. And once this entire loop ends, we have to return. Or also one more thing, once this jump is done in a while loop, so our race value is also going to increase. So race plus equal to 1. See, for the first condition, right, race is going to become, the result is going to be 1. Again, if this for loop is executing, which is denoting that we have to make second jump and we have not yet reached to the end point, so in that case the result value is again going to be 1, and at the end we have to return the result. So this is a greedy approach. There is also another approach, which is the dynamic one. But for this problem, right, it is easier to use greedy approach because we are writing few lines of code and no need to complicate it using the dynamic programming, because greedy is going to be quite efficient. Now, let us look into the Python implementation of JumpGame2. So let us add a variable called result, which is going to denote the maximum or the minimum amount of jump which is going to require us to jump from 0th position to the ith position. Initially, the jump is going to be 0. Let us introduce two variables, L and R. Initially, both of them are starting from 0. So let us write a condition of while loop. While our R is less than length of nums minus 1, and let us add a variable called furthermost, and the value is going to be 0. And let us add a for loop. So for I in range from left indices to right plus 1, and the furthermost value is going to be max of furthermost or nums of I plus I. And let us, once the loop ends, then our L is going to be R and our R is going to be furthermost, and because we have already completed a jump, so the result value is going to be increased by 1, and at the end let us return our result. Let us click on run. We are getting a error. Okay, it would be inside this definition. As you could see, both of the public test cases run successfully. Let us submit our code. And as you could see, our code beats 36.06% of the test cases. And because we are just using one while loop and another for loop, so our complexity would be in the range of big O of n square. But because we are not going to use it till the entire length of nums, it will be lesser than that. So we can say that our code is pretty efficient and we are using a greedy approach. That's all for the video. See you in the next one.